So, how do you use Newton's laws of motion in your daily life? Which law are you specifically talking about? The first law of motion, I believe it's called the law of inertia. Well, I use the first law of motion in my daily life. I believe, if you're talking about the first law, I believe it's when an object stays still, stays still, and an object in motion remains at motion unless acted upon by an outside force. Is that the law we're talking about? Yes, it is. So how do you use it in your daily life? When you are at school for a living, like, what do you do? Well, in my daily life, when I'm at school, I look across the classroom and I see a table and it's not moving because it stays still. And I don't know why, but then I look at Newton's law, first law of motion, and I understand why it stays still. As you can see, when the table is still, it just sits there. But when you push it, it goes. But as soon as no force is applied to the object, it stops. Wow, that's really cool. So, what about when, like, say, like a basketball, when it rolls, like, it's just rolls. How come? I mean, I don't understand. As you can see, when I roll a basketball, it stops because of all the friction applied between the object and the ground. Cool. So, I see the basketball has stopped now. Why is that? Well, as you can see, the basketball is slowly stopped because no force is acting upon it. And the reason why is because of friction. It's because the floor has little microscopic hills and valleys. And also the basketball has little microscopic hills and valleys. That's why it slowly but surely stopped. That's why it stopped, because no motion is on the basketball. Another example of Newton's first law is when a person is on a skateboard, it rolls, and your force of you on it, as you push yourself, you go fast. But as you stop pushing, you don't go anymore because you're not acting upon it with a force anymore. And when you just sit there on a skateboard, you stay still. That's also another example of Newton's first law. As you can see, when I push myself on the skateboard, I go. But after a while, I stop because of all the friction applied. Because I didn't push again, I stopped. But if I kept pushing, I would go faster and keep going. And that's where first law of motion comes in, because whenever an object is in motion, it stays in motion unless acted upon the outside force, friction. Also, when a table is pushed, as you can see, it always, as soon as you're done pushing it, it stops. As you can see, the table is still right now because no force is applied. But when you push it, force is applied, and therefore it moves forward. But as soon as I stop pushing it, it doesn't roll forward, it just stops. Because no force is applied. It means there's no wheels on it. The friction stops it. It is so important to understand this law because you know why a table is still all the time when no force is applied, no outside force. And you know why a ball can roll and when someone throws it, but it stops after a while and doesn't just roll forever because no force is applied and therefore an object is still. And that's why this is so important to understand. Thank you so much for your time. So how do you use Newton's laws of motion in your daily life, specifically the second law?
If you're talking about the acceleration of an object, depends on the mass of the said object and the force applied to the object. Is that the law you're talking about?
Yes, it is. So, how do you use that in your daily life in office of presidency?
Like when I play baseball with my kids, I roll on the ground ball and I slowly see the ball decelerate. As you can see.
Really, that's fascinating. So, how else do you use it in your daily life?
So again, when I'm playing baseball with my kids, I roll them, when they're ready, I roll them a faster ground ball and I see it accelerate. As you can see.
So why does it accelerate exactly? I'm not exactly sure.
The reason why, Ricky, is because when I put more force on the ball, it rolls faster and has mass, and therefore mass times acceleration equals force.
Really, that's fascinating. I never knew that. So, what's another example of the second law of motion, acceleration? Like, what's another example?
Well, Ricky, when I get bored at the president's office, I take out my trusty old tennis ball and then drop it to the ground and watch it accelerate. As you can see.
Why does it accelerate to the ground exactly? I'm not sure.
Well, that's easy, Ricky. The gravity pulls it down.
Wow, that's really something. So, what's another example of gravity pulling stuff to the ground and accelerating it? What's another example?
Well, another example is when I drop a basketball, gravity pulls it to the earth faster because it has more mass. As you can see.
Okay. So, what's another example of gravity? Or, how about not gravity again? Let's go back to rolling. But what about something smaller?
When I go to the office to play mini golf, I hit the ball and it goes faster than the baseball because when I hit it, I put more force on it and it's denser.
As you can see. I don't completely understand. So it's denser, so therefore it goes faster?
Well, that's simple, Ricky. Acceleration times mass equals force.
So why is this law so important to understand?
The reason why it's important is so you know why objects accelerate at a certain rate of speed.
Thank you so much for your time.
No problem, Rick. Anytime.
So how do you use a third law of motion in your daily life?
If we're talking about whenever an object exerts force on another object and the other object exerts force back, then yes, Rick.
Yes, it is. So, how do you use that in your daily life?
Well, when no one's looking, I throw a tennis ball at the wall, and it bounces off the wall, and I wonder why. And then I remember it's because the wall is exerting a force back on the tennis ball, making it bounce back. As you can see, the ball bounces back.
Really, that's fascinating. So, what about another example of Newton's third law?
When I'm at home and I'm bored, I throw a basketball against the wall, and it bounces off and makes more noise because it's harder and has more mass and hits the wall harder. As you can see.
Really, that's really cool. What's another example of Newton's third law? Besides a ball bouncing off the wall, what's another one?
Well, when I was at my house one day, I was boxing and I punched the wall on accident, and it pushed back against my hand and almost broke my hand.
Why would you almost break your hand if you punch a wall?
Because I punched it so hard, it exerted an equal and opposite force on my hand.
As you can see. Ow.
What's another example besides hitting a wall?
Well, when I'm at home and playing with my Nerf gun, I shoot the Nerf and the hammer hits the Nerf dart and it shoots out and exerts an opposite force on the back of the gun, but the gun has so much more mass, it doesn't bounce back with the Nerf dart.
As you can see. Wow, that's pretty cool. That's a different one. So I just want one more example of Newton's third law. Could you give me one?
Well, when you hit a hammer on cement, the cement exerts a force back on the hammer, and that's why it hurts a little when you hit it. As you can see, ow.
Really, that's really fascinating. Thank you for that last one. So why is this law so important to understand?
It's so important to understand so you know why one object exerts force back on another object.
Thank you so much for your time. That will be my last interview. Thank you so much. This wraps up Newton's laws of motion. Thank you so much for all the interviews. Thank you. Thank you.
Oh, yeah.